So one more problem that I want to go through, and don't be afraid that I'm doing this as a separate video. It's just um, a little bit longer on its own, but it's not overwhelmingly long. I thought it would just be better to have this really standalone, so there's kind of a clear break point between most of the content and then one more example problem. This one's a little bit different. So here we're given the derivative of f, right? We're given f prime to start and asked to work backwards to find the original function. And there's a whole, actually that's it, a whole laundry list of things to identify along the way. Why? Because it's all going to help us organize our work later. So here's f prime. Let's find f. We should probably start by identifying all of these things on the side first. They're probably there to help us out. So the x-coordinates of any turning points of f and classify them. So turning points of f, we said occur where the derivative is equal to 0, so my zeros occur definitely here. And actually maybe here as well. So that looks like what, -1, -2, -3. And then is that -3, 4, 5, 6, -7. And classify them. Are they minima or maxima? Well, -3, I'm moving from positive to negative function value. Moving from positive to negative function value, which means my function is going from increasing to decreasing, so I have a maximum. -7, we can assume, if we were to kind of continue this graph out this way, that we're moving from negative function value to positive function value. I have decreasing to increasing of my original function, so I have a minimum here. So the intervals where the function is increasing or decreasing, of course, we're increasing when the derivative is positive and decreasing when the derivative is negative. So f is increasing when x is, well, the function is positive between, looks like between -7 and -3. And it's decreasing everywhere else. So again, we can kind of assume based on the activity around here, and that I'm only showing you the important parts of the function, that from -infinity to -7 and then -3 to infinity are my decreasing intervals because my function value is negative there. So the x-coordinates of the inflection points of f. So the inflection points of f are where the second derivative is equal to 0. Well, how do you find that here? Well, we're given f prime. Right? F double prime is the derivative of the first derivative. So anywhere my slope of f prime is 0, kind of think about it that way, is where I have an inflection point. So that would be here, and here, and here. So those look like approximately 1, 2, 3, 4, -5-ish, 0, and 1, 2, 3, 4. So they're my turning points of f prime, but they are my inflection points of the entire function. So I should have a change in concavity there. Sure enough, intervals where f is concave up or concave down. This is where the double prime is either positive or negative. Thinking about that connection between f prime and f double prime again, that means that f prime is increasing or f prime is decreasing. Remember that we're increasing and decreasing based on the maxima and minima, my turning points. So f is concave up wherever f prime is increasing, and that looks like it's going to be from -7 to, between -infinity to -5, as well as between 0 and 4. And everywhere else, this function is concave down because the derivative is decreasing. All right, so we have all of this information. What can we do with it? Why do we have it? Well, it's here to help us out. So let's put a table together of everything we know. And this table is going to start to get a little bit messy, but that's okay. I'm going to color code these. So we'll do my we'll do my turning points in green, and we'll do my inflection points in blue. You'll see why in a minute. So if I start to organize these from least to greatest, right, if I were to kind of lay out my turning points at -7, -3, and then lay out my inflection points. Let me pick a brighter blue. At -5, 0, and 4. Then we can start laying out all our information. So let's figure out a couple things. We'll start by saying, what's true about the first derivative? Is it increasing, decreasing, positive, negative? What does that mean for the function? And then we'll do the same thing with the second derivative. Is it positive, negative? What does that mean for the function? Okay. So f prime is positive when x is between -7 and -3. So positive all the way up to -3. And I'm actually making a point to go between every single little partition that I have here. You'll see why in a minute. And it's decreasing everywhere else. So back here, should maybe left myself some more room. And then from -3 all the way to infinity. What does this mean? Remember that meant that f is increasing where the first derivative is positive and decreasing everywhere else. Again, you'll see what this means in a minute. All right, well, how about concave up, concave down? F is concave up where the second derivative is positive. So the second derivative was positive from -infinity to -5, and then from 0 to 4, and then negative everywhere else. What does this mean for the function? Well, it's concave up everywhere I'm positive, and concave down everywhere I'm negative. Okay, well, I've got all my information now. It's nice and organized, but what does it mean? What good is this going to do for my sketch? Well, let's look at two key lines. My two function lines here. I have increasing or decreasing and concave up, concave down. Where have I seen this before? That's right. My trusty little chart here that tells me concave up or concave down. So let's convert these into some symbols. Decreasing concave up is going to look like this. Increasing concave up is going to look like that. Increasing concave down, decreasing concave down, decreasing concave up, decreasing concave down. So I have this. You're probably wondering what's going on here. These shapes are going to help us guide the sketch. So all I did was pull those right off of, where'd it go? This chart right here. So we're going to take those now and we're going to apply them to our graph. Well, before -7, I can't really quite sketch that in, but I'll try to just to kind of help myself out. And around -7, you can kind of see around -7, I'm moving from concave up decreasing to concave up increasing. So kind of just around 7, I'm going to start to sketch that in. And then around 5, I'm going from increasing concave up to increasing concave down. So maybe if I start to work this out and then I get to around 5-ish, maybe leave myself a little more space. So start a little bit lower, I guess. And somewhere around 5, I need to change concavity until I get to -3. You see around -3, I'm going to change concavity again. So I'm just going to kind of do one of these until I change concavity again. And I'm going to keep following this until I get to 0. I'm going to keep decreasing. And once I hit 0, I have an inflection point. I'm going to change my concavity. You can see here from to now decreasing concave up. And I'm going to keep doing that until I get to 4, where it turns again and goes decreasing concave down this way. Sort of. Right, so again, it's just a sketch. It doesn't need to be anything perfect. I like to label that it's the actual function so I know where my answer is. This is really starting to put everything together, which is why I made this its own separate little video, especially now that's bordering on 12 minutes long. As you can see, it's not necessarily new information, but it's starting to figure out what to do with it. It's starting to figure out how to organize it, where to go with it, where to play with it. Really important skills now, trying to really piece everything together. Go slow, take your time, do not rush these problems. Stay organized, just like I have. Zoom out so you can see the whole thing. But stay organized just like I have, and this will be much less overwhelming than maybe it looked at first.